Magic morning, everyone. Last meeting, we were able to discuss on distance, displacement, speed, and velocity. Today, let's try to go back to the idea of motion and especially the types of motion. Class, take a good look at these photos. What do you notice about this scene, especially the first one? If you're gonna say that the cars aren't moving because they're stuck, then you're right. These cars are exactly or are in traffic. They're barely moving, if at all. Even though they're designed to move fast, they're at standstill. Now look at this one. What do you see? If you're gonna say they're running, they're fast, then you're correct. These runners are clearly in motion. They're changing position quickly, trying to race or trying to win a race. Now here's the question. Which one is in motion? Is it the cars or the runners? If your answer is the second picture, then you are definitely correct. So what is motion? If we think about motion, we are probably thinking about these examples. Motion is a change of position of an object with respect to a reference point. Some things move fast, others slow, and some not at all. Some go in straight lines, others in circles or back and forth. And today, we're going to explore all of that. We'll learn about different types of motion. First type of motion, rectilinear motion. Motion of an object traveling in a straight line path. Example, when you are walking eastward or westward. Second type of motion, circular motion. From the word circular, meaning it is traveling along a circular path, like bicycle or car moving along a circular track, or for example, the moon around the earth. Third type of motion is the rotational type of motion. Rotational motion. Example, motion of an object rotating on its own axis, like motion of the wheel about its axis, and so on. Then, periodic motion. Motion of an object with repeating movements in irregular time intervals. Example, in a swing or a pendulum. Let's try to assess every situationer and think why is it considered as a certain type of motion. Number 1, since it is a straight line, it is a rectilinear motion. Number 2, circular path, so circular motion. Number 3, in its own axis, so rotational motion. Number 4, straight down the aisle, meaning rectilinear motion. And lastly, since it is in a ballet recital and it's talking about spinning, therefore it's a rotational motion. Now, it's your turn to answer. Please get your science notebook and answer this one. Nice. See how motion can look different depending on the path? Think about your life. How is motion like your personal journey? For example, moving forward or changing direction. And how can understanding motion helps us? Maybe with driving safely or understanding how fast something moves. So how can we really tell that the object is in motion? So let's take a look of this following instruction. What do you guys notice? What are the similarities? Or what is the outcome? If you are going to say that there is a change of position, then you are correct. To answer that question, you will always go back to the definition of what is motion. Again, motion is the change of position of an object with respect to a reference point, like these examples as what I've presented earlier. And as what we've discussed earlier, we were able to identify that position is the location of an object at a certain point in time from a chosen reference point or origin, like these example. As you can see, it can be represented in a number line or in a graph. It helps describe where an object is before or after it moves, like the frog. Initial position of the frog is 2 meters east or positive 2 meters. If it moves 4 meters towards east, its final position becomes 6 meters east or positive 6 meters. And the change of position over a certain period of time is what you call displacement. It is a vector quantity, while distance is a scalar quantity. It refers to how much ground an object has covered during its motion. Distance can be signified as a small letter d, while displacement can be signified in a small letter d with an arrow above. If we are going to recall about the things that we've discussed last meeting, we also talk about instantaneous speed and average speed. Instantaneous speed is a speed at any given instant time, while average speed is the total distance traveled over the total time of travel. They are totally different with one another. And also, if we are going to recall the mother formula for speed, which is distance over time, we could also manipulate that one to get the values or the formula for time and distance. So here are the differences between speed and velocity, just for review. Formula-wise, speed is distance over time, while velocity is displacement over time. So basically, if we have that formula for velocity, we could also manipulate that formula and get the formula for displacement and time. So let's give it a try on a certain problem. A Philippine Airlines plane regularly takes off from Manila at 5:30 a.m. and is expected to land in Zamboanga, 852 kilometers south of Manila, at exactly 7 a.m. What should the average velocity of the plane be if it is to land in Zamboanga City on time? We have two given, 852 kilometers south and a time 1 hour and 30 minutes. First, you need to somehow convert 1 hour and 30 minutes in a single unit, which could be in hours. Then, try to substitute that one, but please bear in mind that 852 kilometers south indicates a direction, and south it should be negative. So that's why you just place negative 852 kilometers, and your velocity as a result is also negative. That negative sign indicates that it is heading towards south. For the remaining period, you are going to answer these questions on your science notebook. Please comment your answers in the chat box. So that's it. Bye everyone. See you soon.